Hello, this is Mr. Bradley, and this video is meant to help you learn how to use Google Sheets to represent and analyze data. Physics is really all about trying to find the relationships between variables, and it's much easier to see what those relationships are when you can graphically represent them, much like in this screen that I'm showing you right here. This is just a sort of pretend data set that I made up to show how the graphing would work. Here I have an object that from time 0 to time 3 seconds was just in different positions over time. And you can see that it started off 4 meters away from what might be the origin, and it got closer to what would be the origin, and then it got farther away from the origin. And this graph would enable me to see what the instantaneous velocity is anywhere along the way, and it would also enable me to get an idea of what the average acceleration might be from one place to another. This isn't a data set that actually represents anything that really happened. This was just a data set that I created. Another data set that I show here in this picture is another sort of weird data set, and again, this one is just showing how you could fit this with a polynomial function that might fit the data. Although, to be honest with you, this particular polynomial function I wouldn't use to actually fit this data. I'll talk more about that a little bit later. So the first thing I want to do is just talk to you about how you would create a graph like what you saw on the previous screen. So within Google Sheets, the first thing you would want to do is access Google Sheets through your Chrome tools. And usually when you open it up, you're going to get an untitled spreadsheet that looks something like this. It's always a good idea to go ahead and just name that spreadsheet so that when you want to get back to it again later, you can do that. And naming it is pretty simple. You just click on where it says untitled, and you can type in the name. Now the next step would be to type in your data set. The way Google Sheets works is that it takes whatever you type in column A and puts it on the x-axis of your graph. And whatever you put in column B, it puts it on the y-axis of your graph. It's a pretty simple type of thing. So what you would want to do is type in the data that you want to graph into column A, but don't forget to put the label for that data at the top of that column. You know, I like to put in what the variable is and what the unit is that represents, or that variable is measured in. So in this time, let's do a time on the x-axis, and we're going to do a speed on the y-axis. Okay, so what we'll be graphing here is something that's speed is changing over time. I'm going to go ahead and take a moment here to put in the data set, and then you'll be able to see the data that I'm going to represent. Okay, so this data set that I provided shows that from 0 to 5 seconds, some object, I don't know, probably a car because it's in miles per hour, is increasing its speed from 0 to 44 miles per hour. So just taking a look at this data set, you can obviously see that the speed is increasing, but in order to be able to see what that pattern might look like, you really need to have a graph to be able to see that. So what we're going to do is use Google Sheets to create that graph. What I'm going to do is basically take my mouse and highlight the data that I want to graph, including the labels, and then I go across the top here to the menu and I click Insert Chart. Now, one of the great features here is that it'll give me some recommendations on the types of graphs we want to look at. And by and large in physics, we really want to use this type of graph right here. This is what we would call an XY scatter plot, where it just graphs the points on the graph. And so now you can start to see a little bit of what the trend might look like in terms of the increase in speed. What I tend to do here when I'm on this step is I go right over here to the Customization tab, and I fix up some of the things right away that I know I'm going to want to have. For instance, I want my graph title to look a little bit cleaner than this, so I'm going to put speed with a capital S. So now it's going to say speed in miles per hour versus time in seconds. That basically just takes the data labels. Now, I could, if I want to, say the speed of a car over time. That's another great title that helps to explain what this is. And I don't know if I wanted to make that look different. I could certainly do that by changing the color of the font and whatever. The legend is basically the data points that I just graphed, and that's going to become pretty important here in just a second. So I'm going to end up putting that legend on the bottom, and you're going to see why I'm going to do that in a moment. So then what I'm going to do is scroll down, and you can make changes here to the horizontal axis or the vertical axis if you wanted to, just by kind of messing around in this particular feature set. It's not necessary because everything already looks like it needs to. So then I'm going to keep going down here. If I wanted to have some more grid lines, I could certainly do that on both axes. That sometimes is helpful, especially if you're trying to read the data out a little bit more, try to interpolate the data within the data, and you'll see what I mean by that also here in just a minute. The scaling just goes off the data. It's a default scale, but you could certainly change that if you wanted to. That's not going to happen in most situations. Okay, now really the big part of the thing, or the big part of the graphing comes down below. If I go all the way down below the customization menu, I get to trend line. And right now I have no trend line shown, but I want to put in a trend line. So it really gives you three options here. You could do a linear trend line, which clearly doesn't show the data that well. You could do a exponential trend line, which again doesn't show the data very well. By the way, exponential is something that we rarely use in physics. Really, we're going to stay with between linear and a polynomial trend line. Now, what it will do is allow me to pick the degree of the polynomial that I want to use. This would be like an x squared or a square root relationship. This would be like an x cubed or a cube root relationship, and et cetera, et cetera. Well, what I would say is that the x squared relationship makes the most sense here for this data, because the x cubed relationship shows that the data goes back down again, and there's nothing that within my data that would make me think that that would actually be the case. So what I'm going to do is stay with the x squared relationship, and then I want the label to be the equation. And so now what I have down below in my graph is I have the equation that describes the data that I have graphed. It's kind of cool because if I move my mouse along the line, you can see that equation right there. So now that I have the graph pretty much looking like I want, I just click Insert, and then I'm just going to drag that over to the side so that my data set and my graph is visible. The graph is customizable if you just click on this graph, and you can go up to Edit, Quick Edit mode, or you could also choose this menu right here and go to Advanced Edit. Or if you wanted to, you could just click on areas of the graph that you want to edit. I mean, this thing is really pretty easy to work with. One of the things I like to do is I like to move and resize the graph a little bit so that it takes up the most space inside of that window that I could possibly imagine. One thing you want to do is make sure that this equation is still pretty visible, because you're probably going to use that in the analysis that you do. Okay, so the last thing that I would recommend to do with this is just to pretty it up a little bit, because in all likelihood you're going to print this out and turn it in with a lab that you do, or make it a part of your lab notebook or something like that. So, I mean, some of the things you could do is within the data set, you know, select it and, I don't know, you know, just make the data set look a little bit prettier, something like you might see in a book. Like for instance, I'm going to, you know, make this font bold right here, and, you know, put some grid lines around the data set, you know, that sort of thing. One other thing I kind of like to do is maybe have like a title, so, you know, if I insert a row above this, it doesn't change the graph because the computer already knows what the data is that you're looking for. So, you know, let's say I don't know, insert a row and just kind of make this big bold row, or big unified row of cells. And I don't know, maybe this is the race car acceleration lab, I don't know what it might be. You know, change the formatting of it just so that it, again, like I said, makes it look a little bit better. Of course, it might help if I spelled the word acceleration right. You know, make the font a little bit bigger, I don't know, something like that. Then when I turn this in, you know, this looks a little bit more professional. a little bit easier to understand. One thing I really want you to recognize here is the value of this equation down below. This equation right here says, y equals negative 1.472x squared plus 16.719x minus 1.99. But understand what this really means, okay? The y variable is actually the speed of the vehicle, and the x variable is actually time elapsed. This last number, of course, is what in this case it's the y-intercept, right? So if I extended the y-axis down below, this is where the data crosses. That's kind of a faulty point, or faulty thing really, because you can see that my data said that at time 0 it was moving at 0 miles per hour. Really, that's just because this line doesn't fit the data all that well, but it's the best fit that can be had. But look, this equation really allows me to predict what the speed of the car would be at any time within this data set, and I don't know, maybe just outside of the data set. I wouldn't use this to predict the speed of the car at 8 or 9 seconds because the trend probably falls apart, but it really does allow me to predict what the speed of the car might be reasonably within this data set. This means speed equals negative 1.472 time squared plus 16.719 time. That's really what this means. And in all the equations that we use in physics, the kinematics equations, Newton's laws, energy equations, any of the equations we use, you understand that that's what they are for. They are used to predict what the value of one variable might be as another variable changes. So that's what the value of this is. So my guess is you're going to be using Google Sheets a lot in this class, maybe even a lot of science classes that you take from here on out. And I hope that this tutorial helped you to understand how to do that a little bit better. Thanks for your time. Have a great day.